Hi, Matt. So this is question number 30. It says the figure above shows a regular hexagon with sides of length A and a square with sides of length A. If the area of the hexagon is 384 square root of 3 square inches, what is the area in square inches of the square? So here, we've drawn that hexagon. We know that we can split it into 6 equal parts. Because otherwise, there's no way we're going to be able to determine a certain side or anything like that unless we divide it up into different shapes. So we divide it up into 6 equilateral triangles, and we think, if the area of the entire hexagon is 384 times the square root of 3, we can divide that by 6 because we have 6 equilateral triangles making up this hexagon. So when we do that math, we actually get 64 times the square root of 3. And now we're trying to ask ourselves, okay, now how can we figure out this piece here? Because this is the main problem, right? What's bothering us is we got to get this piece here in blue. Once we get that, we can multiply it by itself to get length times width to find the area of that square. So we think, oh goodness, we've got these nice equilateral triangles, but we're not really sure how to find any piece of the equilateral triangle. It doesn't seem particularly helpful. So what we're going to need to do in this instance is we are going to go ahead and split that equilateral triangle into 2 right triangles. And then, we think about the fact, well, how do we find the area of a triangle? Because since we know the area of the triangle, we know that the area of a triangle is equal to 1/2 times the base times the height, right? So if we know the area, we can maybe find the base and the height. And, if we could find that base, well, then we'd know this length over here. Okay, so now that you can figure out what the, you can't actually figure out what the base or the height are unless you make 2 30, 60, 90 triangles, and you know your 30, 60, 90 triangle ratios. You're very rewarded for knowing those ratios on this question, and in fact, it is very important. So here, you know that in the 30, 60, 90 triangle, the base, so, if we have 30, 60, 90, the base is going to be x. But remember, that's just one base. Each base is x. So then we know the whole thing is going to be 2x if added together. Okay. Now, we know that in a 30, 60 triangle, the ratios are actually x, x squared root of 3 and 2x. So like this, x squared root of 3, which is the height, and then 2x out here on the side. Okay, so these are ratios you want to come and memorize. I'll just write them out here. X squared root of 3 and 2x. Those are the ratios for a 30, 60, 90 triangle with 2x being that hypotenuse, being the largest, which makes sense. The hypotenuse is always going to be the largest side of of a right triangle. So now we have a lot of information, now that we know our 30, 60, 90 ratios, that we can plug in to our formula. So we're saying, okay, so look at this. 64 square root of 3 is equal to what? Well, we've got our 1/2, and then we got our base. So our base, and remember we're talking about the big triangle again, right? Because we want to know for the big triangle, base of the big triangle is what? It's actually 2x because we have to count both x's. So 2x for the base times the height. What's the height? The height goes right up that center. It's x squared root of 3. Okay, now numbers get a little scary looking, but don't worry. Nothing we can't handle. Okay. We still do have a lot of variables in there, but this is going to be solvable. So watch what happens when we crunch these numbers. These are where our algebra skills come in really handy. So let me move this. I'll move it all down. We have 64 square roots of 3. Look at how we have 1/2 times 2x. When you multiply 2x times 1/2, what do you get? You actually just get plain simple x, right? Okay, and then we also have times x times the square root of 3. Okay, so now we have that x, because this turned into x times the square root of 3, so it ends up being x squared times the square root of 3. Again, looks kind of gnarly, but always looks worse than it really is. What do we see? Aha! We got a square root of 3 on one side, square root of 3 on the other side. That means we can cancel them out. Sayonara. We are in better shape now. 64 equals x squared. Okay, so how are we going to find x? Aha, square root both sides. So the square root of 64 is 8, right? So x is equal to 8, but be careful to look at what do they actually want from us in this equation. They actually want the area of the square, right? So remember that in this case, we're trying to find one side so we can multiply that side by itself, right? So remember, if x is 8, one of these sides is actually 2x, right? Okay, so I'll put side equals 2x, as we determined earlier on, equals 2x, and 2x is what? 2x equals 16. Okay, so one side is 16. Aha, now can we find the area of the square? Absolutely. 16 times 16 will give you 256. You're allowed to use a calculator on this one. No sweat. The answer is A. All right, so to review, to recap, they told us at the beginning the area of the hexagon. That doesn't tell us much, so we need to split the hexagon into 6 equilateral triangles like we did here. Then we see, the base of one of those triangles is the same as one of the lengths of a side of that square. And obviously all the sides are the same because it is a square. So we said, great, let's take our area divided by 6 because that's per triangle. So the area of one triangle is 64 square roots of 3. All right, so we say 64 square roots of 3 is equal to 1/2 times the base times the height. Then we had to have a base and height information about this triangle. We knew by drawing down the middle right here, we can make a 30, 60, 90 triangle if we split this equilateral triangle in half. Once we knew we had a 30, 60, 90 triangle, because it was an equilateral triangle and we drew it in half, it's going to be at 30, 60, 90, and we have these memorized ratios, x squared to 3, and 2x. We apply those. So we say, okay, 64 square root of 3, or the area of the triangle, is equal to 1/2 times the base, which is going to be 2x, because it's 2 of these, times the square root of 3, which is this length right here down the middle, x times the square root of 3. Then we just crunch numbers. Basic algebra, 1/2 times 2x gives us x. We have x squared root of 3, so it's x times x. Gives us x squared times the square root of 3. This is looking a lot nicer because we can cancel out our square root of 3 on both sides. 64 equals x squared. Take the square root of both. X is equal to 8. Then we have a side here. We say, okay, the side is in fact 2x, right? Because we decided that up here. So the side length is 16. Boom, 16. 16 times 16 is 256. The area of the square is 256. Please let me know if you have any questions. Again, happy to talk to you about it more.